Okay, so in this video I'm just going to give you a quick rundown on what the special triangles are in maths. I've mentioned them in a couple of videos before, and now I'm just going to give a quick example of what they are. So these are the special triangles that I mentioned in my previous videos. So as you can see, we have a 45-degree triangle and we have a 30-60-degree triangle. So obviously 45 degrees because we have 45 and 45, and 30-60 because it's a 30-60 triangle. Now these triangles are very special triangles because, as you can see in this circle here, we can get to every single one of these angles by just using a combination of 45 degrees and 30-60 degrees. Okay, so just for example, this angle here is 15 degrees. Now we can get to 15 by taking 30 degrees away from 45. So that gets us our 15 degrees. This is 30 degrees, so obviously that's there. 45 degrees is there. The next one is 60 degrees, which is there. This one is your 75 degree, which is a combination of 45 and 30. And obviously we have our 90 degrees at the top. Now it's the exact same on the other side. You can get to these angles as well using some combination of either one or two of these triangles. So for example, this angle here is 105 degrees. And we can get to 105 degrees by 60 and 45. So as you can see, by combining the triangles in certain ways and using certain properties from the triangles, we can actually get to all of these angles that are outlined here, which becomes very helpful later on in some of the questions. So in this section I'm going to go into greater detail on the 45-degree triangle first. Okay, so as you see, we have 45 degrees here, we have 45 degrees here. Now the important bit is that this side is length 1 and this side is length 1, and using Pythagoras' theorem we can get that this side is root 2. Now we know from the previous video that that is across from the right angle, so that makes it the hypotenuse. So I'll just name my angles for a minute. Now because it's a 45-degree triangle on both corners, what I'm going to do is just focus on this one, and I'm going to name my sides relative to this one. Okay, so this side obviously is opposite and this side is adjacent. Now from a previous video I've outlined what SOHCAHTOA was. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So using this quick memory technique, I'm going to now work out these three ratios. So sine 45 is O over H. O is going to be 1 and H is going to be root 2. So sine 45 gives me an answer of 1 over root 2. Now I'm going to do the exact same for cos. Cos 45, so we need to get the adjacent over hypotenuse. Adjacent over hypotenuse is 1 over root 2. And tan, the final one, tan 45 degrees, is going to be opposite over adjacent, which is 1 over 1, which is just the same as 1. So they are our values for sine 45, cos 45, and tan 45. Now this example is going to be a more detailed look on the 30-60 triangle. So as you can see, we have 60 degrees in this corner and we have 30 degrees in this corner. Because the 60 degree is blue, I'm going to use blue when I'm labeling the opposite and adjacent. And when I'm talking about this angle, the 30-degree angle, I'm going to use red because that's a red angle. So first of all, I'm going to find my hypotenuse. Now, as we know, the hypotenuse is always across from the 90 degree. So this is always going to be hypotenuse. So I'm going to write that in black because that doesn't change. First colour I'm going to do is blue. So the opposite to the 60 degree is this side, which is root 3. So that is going to be my opposite. So that means 1 is going to be my adjacent. Now I'm just going to write it inside the triangle so it doesn't get in the way. Now from the 30-degree point of view, this side is going to be my opposite and this side is going to be my adjacent. So using the red pen, I'm going to call this O and I'm going to call this A for adjacent. So now that we've got all our sides labelled, I'm going to work through the angles at the bottom. So sine of 60, we know that sine of 60 is going to be O over H. So we're looking for the blue O, which is root 3, and the H is going to be 2. So sine 60 is root 3 over 2. Cos 60 means that we're going to look for the blue A, so the blue adjacent, which is 1. And it's going to be over the hypotenuse, which again is the same for all of these angles, which is going to be 2. And tan, from SOHCAHTOA, we know is opposite over adjacent, which is root 3 over 1, which is just the same as root 3. If we change to the 30-degree angle, we're going to use the same steps, but we're going to use the correct sides relative to the 30 degree. So sine, again, we know is opposite over hypotenuse. Opposite relative to the 30 degrees is going to be 1. The hypotenuse is going to be 2. Cos is going to be adjacent, so we're looking for the red adjacent, which is here. So it's root 3 over 2. And tan is going to be opposite over adjacent, which is 1 over root 3. Now I'd just like you to take this opportunity to pause the video and see, can you find any relation or any correlation between the numbers that we have down here relative to their angles. So some of you might have spotted it. If we look at this here, we have sine 60 gives us an answer of root 3 over 2, but cos 30 also gives us an answer of root 3 over 2. And from a different point of view, cos 60 gives us a half, the same way sine 30 gives us a half. And one property we can take from that is sine of one angle is the same answer as cos of another angle, as long as those two angles combine to give 90 degrees. Now, as I pointed out, these triangles are very important triangles, and there's actually a cool trick to help remember what these answers are, called the left hand trick. So as you can see, I have a left hand and each finger represents a different angle. Your thumb is 0 degrees, index is 30 degrees, middle finger is 45, your ring finger is 60, and your baby finger is 90. As well as that, another important bit we need to know is that the left hand side is going to be sine and the right hand side is going to be cos. And here on the right hand side is the formula we're going to use to find out what our answer actually is. How to use this trick? For example, I'm going to try and find what is sine of 30. So what I'm going to do is ignore my index finger or my 30 degree finger, and I am now going to count the amount of fingers on the sine side of this particular finger. So we can see that there's one finger on the sine side. So using my formula here on the right hand side, we can say that it's the square root of 1 over 2, which is the same as a half, which is what we worked out from earlier. On the cos side, we have 3 fingers left over. So using this same formula, we're going to say cos 30 is root 3 over 2, which is what we worked out above. And this technique works for every angle that we have here. I want you to try this one yourself. Using the left hand trick, can you tell me what is sine of 45 degrees? So we want 45 degrees, so we're going to ignore the 45 degree finger. We have 2 fingers on the sine side, so it's going to be the square root of 2 over 2, which is the same as 1 over root 2. Similarly, we have cos 45, which will give us 2 fingers on the cos side, so that leaves us with square root 2 over 2, which is the same as 1 over root 2. And as I said, this works for all your angles. So if we want to talk about 60 degrees, we just ignore the 60 degree finger, or you can put the finger down. Sine of 60 degrees is root 3 over 2. Cos of 60 degrees is root 1 over 2. And root 1, as you know, is 1. So cos of 60 degrees is 1 over 2. Now, since we have a trick for the sine and cos ratios, you're probably wondering, do we have one for tan as well? And the answer is yes, we do. This is our solution. Now, there's a slightly different rule in this case. What we have to do is take both sides of a particular finger. So, for example, if I want to find tan of 30 degrees, well, using my formula, it says the square root of fingers divided by the square root of fingers. Now, that seems a bit strange. So what you actually need to do is take the square root of the left hand side divided by the square root of the right hand side. So by using that method, we have the square root of 1 divided by the square root of 3, because we've 1 on the left and we've 3 on the right, and that gives us a final answer of 1 over root 3, which we'd worked out from above. Now if I take a second example, if I want to find tan of 60 degrees, well, the same thing applies. We'll get rid of this bit and we will ignore the 60 degree finger this time. So tan of 60 degrees, we take the square root of the left side of the ignored finger, which is 3. divided by the square root of the amount of fingers on the right side, which is 1. So we know that tan 60 degrees is root 3 over 1, which is just root 3. So that's the end of this video regarding these special triangles. Hopefully you found it helpful, and in particular I hope you found the left hand rule helpful.